Alright, this is AP Calculus Lecture Section 5.4B. And this is about integrating exponential functions. Alright, so if the derivative, if f of x is equal to e to the x, we learned in the previous lecture that f prime of x is equal to e to the x. So therefore, if we were to take the antiderivative of e to the x dx, that's just going to be e to the x plus c. Now, taking antiderivatives of exponential functions almost always involves u substitution. Okay, so let's start to work some examples. The first one is if we were to have e to the 3x plus 1 dx. So here u would be equal to 3x plus 1. du is equal to 3 dx. So 1/3 du would be equal to dx. So we could rewrite this as 1/3 out front, and then integrand e to the u du. And that's going to be, since the antiderivative of e to the u is just e to the u, just like up here, then that's going to be 1/3 e to the u plus c. And so substituting u back in, that's going to be 1/3 e to the 3x plus 1 plus c. So we can check this by taking the derivative. Okay, so taking the derivative real quick, f prime of x is going to be 1/3 e to the 3x plus 1 times the derivative of the block, which is just 3. And you can see the 1/3 and the 3 cancel, and you're left with e to the 3x plus 1, which is your original function. So you can always check by taking the derivative of your answer. Okay, the second example, we want to find the antiderivative of 10x to the 4th plus 4x times e raised to the x to the 5th power plus x squared minus 1. Okay, so the x to the 5th plus x squared minus 1, that's all an exponent. Okay, dx. Alright, so you want to pick a u so that when you take the derivative of it, it's sitting in the problem. So our u would be the x to the 5th plus x squared plus 1, because when we take the derivative of that, we get pretty close to the 10x to the 4th plus 4x. So let's let u be x to the 5th plus x squared minus 1. Then du would be 5x to the 4th plus 2x dx. So what we need is twice that in order to get this coefficient out front. So 2 du is equal to 10x to the 4th plus 4x dx. So we'll rewrite this as 2 integrand e to the u du. So that's going to be 2e to the u plus c And substituting the u back in, that's 2e to the x to the fifth plus x squared minus 1 plus c. And you can take the derivative of that, and you will get back to your original equation up here. Alright, now we're going to take our example problems from the book. So the first one from the book, we're on page 346. And our example is number 76. Okay, so that shows e to the minus x to the fourth times minus 4x cubed dx. Okay, so this is a pretty simple one because it's pretty obvious. If I let u be minus x to the fourth, then du is going to be minus 4x cubed dx, which is exactly what we need. Right, that's that right there. So I don't even have to put anything in front of the du. So you can rewrite this as e to the u du. And then that's just going to be e to the u plus c, which is e to the minus x to the fourth plus c. Alright, and if you take the derivative of that, you'll come back up to this, the original expression. Alright. Our next example is number 80 from the book. Okay, and that is e to the 2x over 1 plus e to the 2x dx. Now here you got to pick your u, but you know that du can't be on bottom. So the only thing that makes sense to pick for u is 1 plus e to the 2x. Okay, so when we take the derivative of that, we would have our du on top. Okay, so du is going to be e to the 2x, okay, the derivative of 1 is 0, e to the 2x, and then multiply by the derivative of the block, which is 2 dx. So 1/2 du is equal to e to the 2x dx, and that's exactly what I have up here in the numerator. So I can rewrite this as 1/2 out front, and I would have du over u. Now you remember from section 5.1 or 5.2 that the antiderivative of du over u is the natural log of the absolute value of u. So this would be 1/2 times the natural log of the absolute value of u plus c. So that's 1/2 times the natural log of the absolute value of 1 plus e to the 2x plus c. Alright, so you take the derivative of that, it'd be 1 over 1 plus e to the 2x times the derivative of 1 plus e to the 2x, and you would end up getting back to this original fraction. Alright, so two more example problems, and this lecture will be over. The next one is number 88. So that is, on top we have e to the 2x plus 2e to the x plus 1 all over e to the x dx. Now in this case, what you want to do, because u substitution really doesn't work here, you don't end up, if you let the top be u, then du is not going to end up being what's on bottom. So what you want to do is simplifying it, because we have just one variable in the bottom. So let's take that one variable and divide it into each member of the top, and what you're left with is a much easier expression to take the antiderivative of. So e to the 2x over e to the x, all we're left with is you just take the 2x minus x. When you have division, you subtract the exponents, and you have e to the x. And then 2e to the x over e to the x. The e to the x's cancel, and so you just have 2. And then 1 over e to the x we could rewrite as e to the minus x. And then that is dx. So now here we wouldn't use u substitution at all. We're just going to integrate each variable one at a time. So the antiderivative of e to the x is just e to the x. The antiderivative of 2 is 2x. And then the antiderivative of e to the minus x, I'm not going to put the sign in yet. I know it's going to be e to the minus x. But I'm going to need a minus here. So when I take the derivative, I know the derivative of e to the minus x is e to the minus x times negative 1. So that's minus e to the minus x. So in order to get plus, I need a minus sign there. Okay, so you can work through that on your own. If that's confusing, try it on your own. But take the derivative of that and you would end up getting back to this. So let's not forget the plus c. So always try to rewrite if you can to make your life easier. And our last example problem is number 90. And this is e to the tangent 2x times secant squared 2x dx. Alright, so we want to pick a u that when we take the derivative of it, it's sitting in the problem. So the one that makes sense would be u is equal to tangent 2x dx. Excuse me, not dx yet. Alright, so tangent 2x. So du would be secant squared 2x, but then we have to multiply by the derivative of the block of 2x, so that's 2 secant squared 2x dx. Well, I just need it to be secant squared 2x, not 2 secant squared 2x, so 1/2 du is equal to secant squared 2x dx. So now we can rewrite this as 1/2 integrand e to the u du. And that's going to be 1/2 e to the u plus c, 1/2 e to the tangent 2x plus c. Alright, so that concludes today's lecture. The homework that goes with this lecture, so for the people that were in class on Wednesday, this would be due Thursday, is on page 346, 75 through 91 odd. And you can always get this by going to my website, darylwoodard.weebly.com. Okay, pick on AP Calculus tab at the top, and it shows you the homework that's due. Now the homework assignment after this is a review assignment, and I'm going to go ahead and write that review assignment down. It's on the website, but I'll go ahead and write it down since we're videoing it. I'll write it down on this whiteboard if you prefer. So the test review homework is from section 5.1, and here's the page. In fact, I'm sorry about that. Just section, page, and the problems. So section 5.1 on page 319. The problems are 44, 46, 50, and 65. Okay, also from section 5.1 page 402. So that's the review section. We have a couple problems there that might help. 11 and 13. Okay, from section 5.2. It's page 402. And the problems are 19 through 22, all. So both the odds and the evens. Section 5.3, those problems come from page 403. 27 through 32, all. And also study the worksheet. We don't have problems from the book like that. So the worksheet that we did, the second part of section 5.3. And then finally, the review problems for section 5.4 are on page 403. And we have 41, 43, 45,